Welcome and bienvenue and welcome back to the modding of Isaac with Lyte. And a big thank you to iZeravan and Coconut81 who have continued their support of this channel. And if you feel like supporting, head over to patreon.com. $1 is infinity% better than zero. And speaking of better, today's episode is on improving the shaders that we worked on last time. I know I haven't been making as many videos as I had been. It's been a little crazy. That's how it goes. But we have improved our shaders from last time, made it a better grayscale, we got better transitions, and I can demonstrate to you some of the fundamentals of coding for shaders that I may have neglected last time around. So let's head into the game, take a look at the improved quality of the shaders themselves. Probably shouldn't start it as Maggie since she starts with 4 hearts. But here we are. If we are to say take some damage, at the start it doesn't do anything because the shaders are set to react to having less than 3 hearts, which we now have. It was a very subtle change. It took some time, it transitioned very smoothly. And so if we take a little bit more damage, it's a nice smooth transition from each level of damage to the next. We still get a nice bright Maggie and some decently bright enemies, but the rest of the shadows are nice and shadowy. It gets a better balance of brightness than our previous shader that kind of washed everything out. It kind of blurred everything together. You lost the contrast that's necessary for keeping a good eye on your main character versus all of the background elements. It wasn't a huge change to make this happen, so let's go take a look at the code and we'll see exactly how it works. So here we are in the main.lua, where we've added a few things to the code we had before to add primarily the smooth transitions. So up here we have gray amount, which is how much, well, not so much the gray as the saturation, really. But it's going between 0 and 1, as it did previously. It starts out at 1, and then we have our gray target, which is where we're trying to get to with our gray. When you first load the mod, it's gray amount. And if you noticed when I first started the run, we're actually missing something for this code. We don't actually reset it to 1 when we first start the run. So it actually started with the old shade from the previous run and then brought it up to 1, which I don't really mind. It was kind of a nice effect. And then, so if you wanted to add that, you could just do a first frame thing where you reset it to the amount that you want. But I kind of liked the way it worked. I might actually keep that. And here we are with a constant gray step. That's the size of the step you take from your current gray amount towards your gray target, such that you slowly, frame by frame, transition from where you are to where you're going, such that you don't have that really abrupt shift of colors. Because I didn't really like the way that abrupt shift looks, and you might not have necessarily thought through how you would do that yourself. Now, this part is the same as last time. We got the shader name, we got the shader params, we grab the player, we check how many hearts they have, and divide it by 6, and take the minimum of that versus 1. So if this is huge because you got lots of hearts, it just comes out as 1, it's totally ordinary. If it's less than that, then you set the target to be that new value. Then, if the gray amount is bigger than the target, you subtract the gray step. If it's less than the target, you add the gray step. There's no super clean sign function in this, where you could just add gray step times the sign of the difference. Lua doesn't have a nice clean sign function, and even if it did, this is what it would do anyway. Just, if this, otherwise that, if they're equal, it'll be 0. So if they are in fact equal, nothing will change. If it's greater, you subtract. If it's less, then you add. It just steps slowly from one to the other. Granted, at many frames per second, it steps pretty darn quick. Which is why we have such a ridiculously small step. Such you can take a lot of really tiny steps from where you are to where you're going. And then we added a parameter. Before we just had the amount. Now we also have a curve constant. Now this is how far it bows away from where it was. That'll make a little more sense in a second when I actually show you what I'm doing to the colors. But that's all we have in the main.lua. This is just setting up the parameters that we send over into our shader and animating them from where you are to where you're going. So if we head over into the shaders, most of this is the same as before, but we added a parameter for the curve value. It's a float, it's just a regular old number. And so we have attribute, float, curve, semicolon. Semicolons are very important in here. In Lua, who cares about semicolons? Here, they are all important. It's very easy to leave them out, and then you get a really cryptic error about some unknown token or unexpected token. Always have your semicolons. Then we have the varying float curve out, which is for passing it from our good old vertex shader into our fragment shader. Just like our amount out, we have curve out gets passed along to our fragment shader. Now we've got a little something extra here. Before we get to that, you still have the varying medium precision float curve out. But we also have another function. That's right, in these shaders you can write your own functions that do your own things if you need to do them a lot. Now, it isn't strictly necessary for what I'm doing here because you only use it once. You could just put this code here. But I wanted to show you what goes into making a function, because you might want to do something more complicated than this, or do it more than once, or apply it to various different things. Because we could curve the color like we curve the gray. I didn't feel like it, but you could. So when you come into your sampler, it by default goes to the void main function. It comes in here and runs things one at a time. It grabs the color, then I have it compute the gray from a perceptual model of how much each of these colors contributes to your sense of brightness. And then I tell it to curve that gray with curve out, which is that constant 0.618 that I gave it at the very beginning. So that takes these values and throws them up here to our curveIt function, which returns a float. Now, these shaders are strongly typed. Unlike Lua, which doesn't care what values any given thing takes, so they just use the word function, because it'll return whatever you tell it to return. These shaders will return only what you tell it. So instead of saying function, you say float, because this curveIt function is going to hand back a number. And then what you hand it is also strongly typed. You have to tell it to expect a number. Not a string, not a vector, a number. In our case, the value, and then another number, the offset. Separate them by comma. So float is what type, the value is its name. Float is its type, offset is its name. And then instead of using local, we use the type. So float curved. Curved here is a variable of type float. Its value is the maximum of 0 and the minimum of this other pair of things. So we want it to be between 0 and 1. And if it ever gets outside of that, we clamp it down to 0 and 1. So if it's bigger than 1, it becomes 1. If it's less than 0, it becomes 0. Otherwise, we've got this value in the middle. So we take the value that it's sent, and then we subtract the sign. This is S-I-N-E, not S-I-G-N. So the good old-fashioned trigonometric function, sine, of the value, times the offset, which is our curve out. So this offset is 0.618 times the sine. So sine starts at 0. It goes up to 1, but not straight up. It curves a bit. So at 0, the way it's moving is like the line from 0 to 1. But then it curves away from it, getting to the value 1, not at 1, but at 1.57 blah 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 blah, which is half of pi. So from 0 to 1 in the span of pi over 2 instead of in the span of 1. So it gets there slower than a normal line from 0 to 1. And then it would go back down to 0 as well. So what this right here all represents is changing what would normally map, say you had the value 3. 3 in, if you had a straight line from 0 to 1, that 3 in would give you 3 out. Because in that straight line from 0 to 1, x equals y. Okay, are you following? Follow. What we're going to do is curve that line, such that instead of putting in 3, or, well, we're only working between 0 and 1. So putting in 0.3 gives you 0.3 before, not anymore. We're going to curve it a bit, such that when you put in 0.3, you get a little bit less than 0.3 back out. And as you go along, you don't get quite as much out of it. But it curves back up towards it, towards the original line. So our brights stay a little brighter than our shadows. So the highlights are a little brighter than they would be otherwise with the shadows. So we decrease the brightness overall, but we increase the highlights relative to everything else that's going on. I know it's a weird sort of thing, but this little bit of math here is what makes it look the way I wanted it to look. You might not want it to look this way. You might want to use some other set of values. You might want to use, say, val over 3.14159. So by dividing the value by pi... Oh, wait, we don't want to divide by pi. We want to multiply by pi. Why? Well, at pi, sine is back to 0. So it started at 0, goes to 1 at pi over 2, it's back at 0 at pi, which means the end points will stay fixed. 0, 0, and 1, 1 will be exactly the same. But it'll curve away from the line, making it darker in the middle. So the brights will be just as bright, the darks will be just as dark, and the mid-range will be pulled down into the shadows. It works okay. It gives you really bright highlights and really dark shadows. It's okay, but it hurt my eyes a bit. It didn't really follow the way I thought it looked. It gives it too much contrast for me. And then I tried over 2. And for all of these, you'd have to change the offset to work well, because 0.618 is crazy for the contrast. Down around 0.2 is okay for that. And if you divide it by 2, it's 0 to 1 that this is doing, and so the offset will make the highlights pretty dark. And so that one really didn't work for me. So this is the one that I liked the best. But again, you don't have to curve it like this. Anything that's continuous will look nice. So you could use 2 straight lines. One that moves the shadows darker and then brings you back up to full. Heck, you could even send it back the other way to give it a more washed out, angelic, sun coming from nowhere feeling. But the important part is you can send it off to a function, have it do something to it, and then bring it back to be used for your shader. And then, if you wanted to do something else, you just change this one little bit of code and see what it does. In future shader episodes, we'll actually talk about using some of this other information to determine where on the screen things are happening to be able to actually change the geometry of what's going on, or at least reference the geometry for what you're trying to do. This right now is ignoring space. All it is doing is looking at color and modifying it. But you can look at the space. You can make it all wobbly like you're underwater. You could flip it upside down, make left into right. You could invert it like one of those photographic negatives. You could do photographic negatives doesn't use geometry either. But the next episode I make, I would like to make it such that you can have a ring of color that goes in a gradient towards the edges, such that you can give that sense of impending doom. Or some other sense. I don't know which sense you want to give it, but essentially you'd put things in the periphery of their vision to add some emotion to it. But that's going to be next episode. This one is just on showing you the importance of semicolons, how to add additional parameters, how to create a function that does what you want. So this return curved says hand it back into the other variable. Using strict typing for the names of your variables and the types of functions, and just that you can use a function at all, and also to animate your values such that you get nice, smooth transitions. That's all I've got for this episode. I will see you in the next episode of the Modding of Isaac with Lyte.